October 26th, 2025, 8:47 p.m. UTC. In exactly 72 hours, 3I Atlas will reach Perihelion, its closest approach to the Sun. At a distance of 0.76 astronomical units, roughly 114 million kilometers, solar radiation will deposit gigawatts of energy onto its surface. For a natural comet, this is the moment of truth. The moment when intense heating triggers dramatic outgassing, when internal pressures build to breaking points, when we finally see spectroscopic signatures revealing what this object is actually made of. For an interstellar visitor carrying ice and rock from another star system, Perihelion is the cosmic stress test that separates theory from reality. But here's the problem. We won't see any of it. On October 29th, at approximately 6 a.m. UTC, when 3I Atlas makes its closest pass by the Sun, the object will be on the opposite side of our star from Earth's perspective. Every ground-based telescope on the planet will be useless. Every major observatory, every amateur astronomer with backyard equipment, everyone who's been tracking this object since its discovery in July, all of them will be staring at empty sky, while the most critical moment of this encounter happens behind a 150 million kilometers of nuclear fusion. If you're as fascinated by this mystery as I am, hit that like button and subscribe. Tell me in the comments where you're listening from, what time it is there, and whether you think this timing is coincidental or something more. Now let's talk about what's really going on. The timing feels almost deliberate. On October 3rd, 7 spacecraft from 4 different space agencies were positioned to observe 3I Atlas during its closest approach to Mars, just 29 million kilometers away. The European Space Agency released images 4 days later. Fuzzy, low-resolution photos that showed nothing more than a white dot moving against a star field. NASA, with its Mars Reconnaissance Orbiter equipped with the most powerful camera ever sent to another planet, has released nothing. 23 days later, still nothing. The HiRISE camera aboard that orbiter has a resolution of approximately 30 kilometers per pixel at the distance 3I Atlas was observed, more than 10 times better than what the ESA cameras achieved. If there's structure, if there's anything unusual about this object's shape or surface, HiRISE would have seen it. The official explanation is the United States government shutdown. Over 15,000 NASA employees, more than 80% of the agency's workforce, have been furloughed. The website isn't being updated. Public communications have ceased. It's bureaucratic paralysis at the worst possible moment. But here's what doesn't add up. China's Tianwen-1 orbiter was also positioned to observe 3I Atlas with its moderate resolution imaging camera. Complete silence. The UAE's Hope orbiter, equipped with the Emirates Exploration Imager, had a clear shot as well. Nothing. Multiple space agencies, multiple sovereign governments, with completely separate bureaucracies and priorities, all simultaneously unable or unwilling to release their best data on the most scientifically significant interstellar object to visit our solar system in years. And now, 72 hours before perihelion, we're flying blind into the most important observation window of this entire encounter. Let's talk about what perihelion actually means. When a comet approaches the Sun, solar radiation heats its surface. For objects made primarily of ice, water ice, carbon dioxide ice, frozen methane, and ammonia, that heat causes sublimation. The ice doesn't melt. It turns directly from solid to gas, creating the characteristic coma, the temporary atmosphere that surrounds the nucleus, and the tail that streams away from the sun, driven by solar wind and radiation pressure. The closer a comet gets, the more intense the heating, the more vigorous the outgassing. At 0.76 AU, the distance 3I Atlas will reach on October 29th. Solar intensity is about 1.7 times what Earth experiences. That's enough energy to drive massive outgassing. That's enough to potentially fracture the nucleus if internal pressures exceed structural limits. We've seen it happen before. Comet 73P, Schwarzmann-Bachmann 3, broke apart during its 2006 perihelion passage, fragmenting into dozens of pieces that continued orbiting the Sun as a debris stream. Comet Linear C2000 WM1 disintegrated entirely, leaving behind only a cloud of dust. Comet Ison, the so-called Comet of the Century, shattered as it passed within 1.2 million kilometers of the Sun in 2013, disappointing millions who had been promised a spectacular show. At 114 million kilometers, 3I Atlas won't experience the extreme tidal forces and heating that destroyed Ison. But it's close enough for thermal stress. Close enough that if this is a natural comet, we should see evidence of strain. Brightness surges from enhanced outgassing. Spectroscopic lines from water vapor, carbon monoxide, carbon dioxide, cyanogen, diatomic carbon, all the molecules that make comets chemically active, possibly even fragmentation if the nucleus has internal weaknesses. That's what we'd see, if we could see it. But we can't. Dr. Avi Loeb, the Harvard physicist who's been tracking 3I Atlas since its discovery, put it bluntly in his October 3rd blog post, published on the day of the Mars flyby. If 3I Atlas is a natural comet, it may erupt in a flare of outgassing or break up into icy fragments soon after perihelion passage. The sunlight will deposit gigawatts of power onto its surface. That energy has to go somewhere. For ice and rock, it goes into vaporization, sublimation, possibly structural failure. Standard cometary physics. Predictable outcomes. But then Loeb added the alternative. Alternatively, if it is technological, it may maneuver to benefit from the Sun's gravitational assist or release probes that could intercept Earth or other planets owing to its retrograde orbit, opposite in direction to the motion of the planets around the Sun. Read that again. Release probes that could intercept Earth. He's not talking about passive observation anymore. He's talking about active deployment. And the retrograde orbit is key here. 3I Atlas is moving opposite to the direction planets orbit the Sun. That means any probe it releases doesn't have to fight against planetary motion to reach us. It can simply drop into an intercept trajectory and let orbital mechanics do the work. From behind the Sun, hidden from our view during perihelion passage, it would be trivial to launch something toward Earth that wouldn't be detected until it was already close. Loeb went further. In the same blog post, he wrote, "When you look at the Sun in the coming weeks, keep in mind that 3I Atlas is passing behind it. If 3I Atlas will maneuver towards Earth when it reappears on the other side of the Sun, the financial markets may crash." Financial markets may crash. That's not metaphor. That's not hyperbole meant to generate clicks. He's suggesting that if this object demonstrates technological capability, if it alters course toward Earth after perihelion, the economic and social consequences would be immediate and severe. Stock markets respond to uncertainty. Wars, pandemics, natural disasters, all of these create uncertainty that translates into market volatility. but the uncertainty of a potentially hostile or at least non-natural interstellar object actively changing its trajectory toward our planet. That would be existential level uncertainty. The kind that crashes markets because suddenly every assumption about our place in the cosmos, about whether we're alone, about whether we're being observed or visited, all of it gets challenged at once. And here's what makes this countdown so frustrating. The timing of everything compounds the problem. The United States government shutdown began on October 1st, 2 days before the Mars flyby. That means NASA was already offline when the best observational data was being collected. The shutdown continues now, 26 days later, with no resolution in sight. Congress is deadlocked. Federal agencies remain paralyzed. And 3I Atlas, indifferent to human politics, continues on its trajectory toward perihelion in 72 hours. Amateur astronomers can't help. The object is currently too close to the sun in Earth's sky, lost in solar glare, impossible to observe with ground-based equipment. By the time it emerges from behind the sun in mid-November and becomes visible again from Earth, perihelion will be over. Whatever happened will have already happened. We'll see the result, the aftermath, but not the event itself. There is one group watching, or trying to. The Galileo Project, led by Avi Loeb himself, operates 3 observatories. One in Massachusetts, one in Pennsylvania, one in Nevada. They're equipped with high-resolution cameras, infrared sensors, and radio receivers designed specifically to detect anomalous aerial phenomena. During late October and early November, all 3 observatories will be in maximum operational mode, monitoring the skies for anything unusual. If 3I Atlas releases probes, if there's enhanced UAP activity correlated with its perihelion passage, if something enters Earth's atmosphere that shouldn't be there, the Galileo instruments might catch it. Might being the operative word. 3 observatories covering a small fraction of Earth's sky. If something comes and it avoids those specific observation zones, if it enters the atmosphere over the Pacific Ocean or the Sahara Desert or anywhere else not covered by those 3 telescope arrays, we'll miss it entirely. The Galileo project is a net, but it's a net with very large holes. And we're trying to catch something that, if it's technological, probably has the capability to avoid detection if it wants to. So here we are, 72 hours from perihelion, 23 days since the Mars flyby, with still no HiRISE images released. 4 months since 3I Atlas was first detected entering our solar system with a trajectory that has a less than 1% probability of occurring naturally. Weeks since anyone publicly confirmed whether radio telescopes have been pointed at this object to check for transmissions. And the best observation window we'll ever have, the moment when solar radiation will test whether this is ice or something else, happens behind the sun, where we can't see. If this were a novel, if this were science fiction, the timing would feel too convenient. The protagonist would say, of course the government shutdown happened right before the critical observation. Of course perihelion occurs behind the sun. Of course all the major space agencies are silent at the exact moment we need information most. And readers would complain that the plot was contrived, that real life doesn't align coincidences this perfectly. But this isn't fiction. This is October 26th, 2025. This is real. And in 72 hours, 3I Atlas reaches perihelion. We won't know what happens during those hours. We won't see the solar radiation hammering its surface. We won't detect the spectroscopic signatures that would tell us its composition. We won't observe whether it fragments like a natural comet under thermal stress or remains intact like something designed to withstand far worse. All we'll know is what it looks like when it reappears in mid-November. Either fragments of a shattered comet drifting through space, confirming everything mainstream science predicted, or an intact object on a potentially altered trajectory, forcing us to confront questions we're not prepared to answer. 72 hours. That's all we have before 3I Atlas disappears behind 150 million kilometers of nuclear fusion. And when it emerges on the other side, we'll either breathe a collective sigh of relief as another interstellar visitor passes through our neighborhood uneventfully, or we'll be staring at data that changes everything. The countdown continues. The silence from institutions persists, and the clock is ticking. October 3rd, 2025. Mark that date. Because on that day, 7 spacecraft from 4 sovereign nations were positioned to capture the clearest images humanity would ever get of 3I Atlas before it disappeared behind the sun. The object was passing Mars at a distance of approximately 29 million kilometers, close enough that even modest instruments could capture useful data. This wasn't a fleeting opportunity measured in minutes. The observation window lasted hours, with multiple spacecraft able to track the object as it moved through Martian sky. 7 spacecraft, 4 nations, 1 fuzzy photo released to the public. And 23 days later, we're still waiting for the rest. Let's walk through what should have been a historic moment in observational astronomy, and instead became a case study in institutional silence. The European Space Agency's ExoMars Trace Gas Orbiter was the first to release images, 4 days after the flyby on October 7th. The TGO carries the CAS's camera, the color and stereo surface imaging system, designed primarily to photograph Mars's surface from an altitude of 400 kilometers with a resolution of about 4.5 meters per pixel. It's an impressive instrument for its intended purpose, but pointing it at 3I Atlas, an object 29 million kilometers away that's roughly 10,000 to 100,000 times fainter than the bright Martian surface it was built to photograph, pushed the system to its absolute limits. The resulting images showed exactly what you'd expect from equipment operating at the edge of capability: a fuzzy white dot moving slowly across a starfield. The angular resolution at that distance worked out to approximately 340 kilometers per pixel. For context, the estimated nucleus size of 3I Atlas, based on brightness and distance calculations, is somewhere between 5 and 46 kilometers across. That means the entire solid core of this object would occupy, at best, a fraction of a single pixel in these images. Nick Thomas, the principal investigator for the CAS's camera, acknowledged the challenge in ESA's official statement. This was a very challenging observation for the instrument. The comet is around 10,000 to 100,000 times fainter than our usual target, the surface of Mars. So the ESA released what they had: images that provided zero new information about 3I Atlas beyond confirming it exists and moves. Within hours of publication, the backlash began. Amateur astronomers pointed out that they were capturing sharper images of comets millions of kilometers farther away, using equipment that costs a fraction of what the ESA spent on CASIs. The most viral post came from an account called Astronomy Vibes on X, formerly Twitter, a side-by-side comparison. On the left, a crisp, detailed image of Comet Lemon captured by an amateur astrophotographer with a standard mirrorless camera and a telephoto lens. On the right, ESA's image of 3I Atlas. The caption, "If a simple mirrorless camera can catch Comet Lemon, why can't NASA capture 3I Atlas passing close to Mars?" The post currently has over 40,000 reposts and counting. But here's what made people truly angry. The ESA wasn't the only agency with spacecraft positioned for observation. NASA's Mars Reconnaissance Orbiter was there. And the MRO carries HiRISE, the high-resolution imaging science experiment, the most powerful camera ever sent to another planet. HiRISE was designed to photograph Mars from orbit with resolution so precise it can distinguish objects the size of a kitchen table on the Martian surface. When 3I Atlas passed on October 3rd, HiRISE had an angular resolution of approximately 30 kilometers per pixel at the object's distance. That's more than 10 times better than what the ESA achieved. If there's structure, if there are surface features, if there's anything about this object that doesn't fit the natural comet profile, HiRISE would see it. The level of detail would be unprecedented for an interstellar visitor. We'd finally have images clear enough to settle some of the questions that have been swirling since July. Avi Loeb said it explicitly in his October 7th blog post. The brightest pixel in the HiRISE image will provide the best constraint yet on the area of 3I Atlas. We are all hoping that the HiRISE team will release their images as soon as possible. That was written on October 7th, 4 days after the flyby. Today is October 26th. Still nothing. The official explanation is the United States government shutdown. Over 15,000 NASA employees, more than 80% of the agency's workforce, have been furloughed as of October 1st, 2 days before the Mars flyby. The NASA website isn't being updated. Public communications have ceased. Press releases that would normally go out within days of significant observations are stuck in bureaucratic limbo. No staff to process data. No one available to write and approve public statements. It's paralysis at the worst possible moment. But let's think about the timeline. The government shutdown started October 1st. The Mars flyby happened October 3rd. That means HiRISE captured its observations while NASA was already offline. Data was collected, transmitted back to Earth, received by ground stations, and then what? Did anyone even process it? Are the images sitting on a server somewhere waiting for furloughed employees to return? Or were they processed immediately by skeleton crew staff who aren't authorized to release anything without proper approval channels? We don't know. Because NASA isn't saying. Because there's no one there to say anything. Except the government shutdown excuse only works for NASA. It doesn't explain China. It doesn't explain the UAE. China's Tianwen-1 orbiter, which arrived at Mars in February 2021, carries the Mars Orbiter camera, a moderate-resolution imaging system. It was positioned to observe 3I Atlas during the October 3rd flyby. The Chinese space program operates completely independently of American politics. They're not affected by congressional budget fights. They don't shut down when the US government does. And yet, as of October 26th, 23 days after the flyby, China hasn't released a single image. Not even a fuzzy dot like the ESA provided. Complete silence. The same goes for the United Arab Emirates. Their HOPE orbiter, equipped with the Emirates Exploration Imager, had a clear observational window during the October 3rd flyby. The UAE space program is small but capable, and they've been forthcoming with data from their Mars mission since arrival in 2021. But on 3i Atlas, nothing. No images, no statements, no acknowledgement that they even attempted observations. Multiple space agencies, multiple sovereign governments with completely separate bureaucracies, political systems, and priorities. NASA blames a government shutdown. But what's China's excuse? What's the UAE's excuse? Why are 4 separate space programs operating in 4 different countries, all simultaneously unable or unwilling to release observational data on the most scientifically significant interstellar object to pass through our solar system since 2I Borisov in 2019? The pattern is hard to ignore. Now let's talk about what else happened on October 3rd, because the Mars flyby wasn't the only anomaly that day. NASA's Perseverance rover, sitting in Jezero crater on the Martian surface, captured something in the night sky above. The image, taken by the rover's right navigation camera, showed an elongated streak of light, roughly 4 times longer than it was wide. At first glance, it looked like a typical long-exposure capture of a moving object. Comets and asteroids often appear smeared in images when the camera exposure time is long enough to capture their motion against the background stars. Standard stuff. Except the math didn't work out that way. When people started calculating the apparent size of the streak based on Perseverance's known camera specifications and the distance to 3i Atlas at the time, they arrived at a disturbing number, approximately 50,000 kilometers long. That's not a comet nucleus. That's not even a comet with a tail. That's nearly 4 times the diameter of Earth. If the streak represented the actual physical size of 3i Atlas, we were looking at something incomprehensibly large. Social media erupted. Was 3i Atlas actually a massive cylindrical craft? Had it been masking its true size behind a diffuse cloud of gas and dust this entire time? The speculation reached high enough that Representative Anna Paulina Luna, a member of the United States House of Representatives, known for her interest in unexplained aerial phenomena, reached out directly to Avi Loeb for his analysis. Think about that for a moment. A sitting member of Congress felt compelled to contact a Harvard physicist about a photograph from Mars. That's not normal protocol. That suggests someone in official channels was concerned enough to want expert interpretation outside the usual NASA communication pipeline. Loeb's response was thorough and, on the surface, reassuring. He calculated that the Perseverance navigation camera has an angular resolution of 0.33 milliradians per pixel. At the distance of 3i Atlas, when the image was taken, approximately 38 million kilometers, that translates to about 12,500 kilometers per pixel. The streak in the image spans roughly 4 pixels, which gives you that 50,000 kilometer length. But Loeb argued this was an artifact of composite imaging, not a representation of the object's actual size. The streak wasn't showing 3i Atlas. It was showing the path the object traced across the Martian sky during a long integration time, likely around 10 minutes of stacked exposures. His reasoning was solid. Mars orbits the Sun at 24 kilometers per second. 3i Atlas was traveling at 67 kilometers per second relative to the Sun in the opposite direction, giving it a relative velocity of over 90 kilometers per second compared to Mars. Over 10 minutes, that's exactly 54,000 kilometers of travel, perfectly matching the observed streak length. The shape wasn't the object. It was the object's motion smeared across time, Case closed, right? The cylinder theory debunked by basic physics and careful math. Except Loeb included one sentence in his analysis that conspiracy theorists latched onto like a lifeline. He wrote, "If the NavCam images represent single snapshots with an exposure time below 3.28 seconds, then the brightness and angular length of the observed source imply that it is not 3I Atlas. In that case, the source might be much closer to the camera, capable of being smeared into an elongated image with a smaller spatial size and a smaller speed. Wait, if these are single-frame captures with short exposure times, then what Perseverance photographed wasn't 3I Atlas at all. It was something else, something closer to Mars, something that moved fast enough to create that streak in just a few seconds rather than 10 minutes. That qualifier opened a door that no amount of subsequent clarification could fully close. Because NASA hasn't confirmed whether the Perseverance image is a composite stack or a single frame. They haven't released the metadata. They haven't provided the exposure time or the number of images combined. The government shutdown excuse applies here too. No staff to process Freedom of Information requests. No one available to confirm basic technical details about how the image was captured. So we're left with two possibilities. Either the 50,000 kilometer streak is a motion trail from 3I Atlas over 10 minutes, or it's something else entirely, something closer, something that hasn't been identified. And NASA, China, the UAE, none of them are clarifying. October 3rd, 2025. 7 spacecraft positioned for historic observations. 1 fuzzy photo released 4 days later. 1 unexplained streak photographed by a rover on the Martian surface. And 23 days of silence from every space agency that should be talking. 72 hours from now, 3I Atlas reaches Perihelion, and we still don't know what we're actually looking at. On October 3rd, 2025, the exact same day, 7 spacecraft from 4 nations were positioned to capture historic images of 3I Atlas during its Mars flyby. A Portuguese amateur astronomer operating under the username Dobsonian Power uploaded an image that immediately went viral. Using nothing more than a solar telescope from his backyard and some aggressive digital enhancement techniques, he captured what appears to be angular structure within 3I Atlas. Dark geometric shapes, protrusions that don't match the typical diffuse glow of a comet's coma, edges that seem too regular, too defined, too deliberate to be random ice and rock. The caption he added was simple, but loaded with implication. What on earth is it? Within 6 hours, the image had been shared across every major astronomy forum, subreddit, and social media platform dedicated to space observation. The reaction split into 2 camps almost instantly, and the divide was as predictable as it was fierce. One group saw clear evidence of artificial structures, proof that 3I Atlas is not what mainstream science claims it to be. The other group dismissed it as classic pareidolia, the human tendency to see patterns where none exist, amplified by processing artifacts from inappropriate equipment being pushed beyond its design limits. The debunkers had solid technical arguments. Solar telescopes use specialized filters designed for observing the sun's extreme brightness, hydrogen alpha filters that isolate specific wavelengths of light emitted by the sun's chromosphere. These instruments are built to handle the intense luminosity of our star at close range, not faint, deep space objects traveling at interstellar velocities millions of kilometers away. When you point a solar telescope at something it wasn't designed to photograph, you're asking the equipment to perform outside its operational parameters. The results are unreliable at best. Add aggressive digital enhancement to compensate for the inadequate setup, and you're essentially asking algorithms to invent details that aren't really there. You're amplifying noise alongside signal, creating structure where there might be none. It's the astronomical equivalent of enhancing a blurry photograph until you start seeing faces in the static, patterns that emerge not from the original data, but from the processing techniques themselves. Fair criticism, technically sound, and if this were just some random internet user with a cheap telescope and too much imagination, that would be the end of the story. Debunked. Move on. But here's where the narrative gets complicated. Dobsonian power isn't some random conspiracy theorist with a telescope and a YouTube account full of wild speculation. He's a respected amateur astronomer who's been sharing legitimate astrophotography work for over a decade. His YouTube channel features careful documentation of his equipment, his observational methods, his image processing workflows, videos showing how he captures planetary transits, how he photographs sunspots during solar maximum, how he processes raw telescope data to bring out fine details while minimizing artifacts. This isn't someone trying to manufacture evidence for clicks. This is someone with a track record of producing credible, scientifically useful observations. And when pressed on the anomalous structures in his 3i Atlas image, he didn't double down with wild claims. He didn't start selling t-shirts with "I found the alien ship" printed on them. He didn't monetize the controversy or lean into the speculation. Instead, his response was measured, scientific, appropriately cautious. He acknowledged the limitations of his equipment. He admitted that solar telescopes aren't ideal for this type of observation. He recognized that aggressive enhancement can introduce artifacts. And he promised to try again when 3i Atlas becomes visible from Earth in early November, after it emerges from behind the sun during perihelion passage. That's not the behavior of a hoaxer. That's the behavior of someone who captured something unexpected, isn't sure what it means, and is being honest about the uncertainty, which makes the reaction to his image even more telling. Within 24 hours of the image going viral, multiple websites published articles specifically debunking his capture. Amateur telescope captures strange 3i Atlas image. Here's why it's not what it seems. Experts explain why viral comet photo shows processing artifacts, not alien structure. The 3i Atlas controversy, how digital enhancement creates false anomalies. The timing felt coordinated. The tone felt defensive, as if someone needed to quickly establish the narrative that nothing unusual had been photographed, that any apparent anomalies were merely technical artifacts before the image could gain too much traction and seed doubt in public consciousness. And then the enhancement wars began. Users across Reddit, Twitter, and various conspiracy-focused forums started downloading the original ESA images released on October 7th and running them through their own processing algorithms. Some used standard astronomical image stacking techniques, methods that have been validated through decades of astrophotography practice. Others employed AI upscaling tools designed for enhancing low-resolution photos. Neural networks trained on millions of images to reconstruct fine details from limited pixel data. A few went full chaos mode, with machine learning models specifically trained to identify geometric patterns, to recognize edges and structures, to distinguish signal from noise in ways that human eyes can't. The results varied wildly. Some enhancements showed nothing but slightly sharper versions of the same fuzzy dot the ESA released. A white blob moving against stars, no additional detail revealed. Others, using more aggressive processing techniques, revealed what appeared to be distinct geometric patterns, edges, structures that seemed too regular to be natural ice and rock, variations in brightness that suggested surface features rather than uniform diffuse material. The problem, and this is critical to understand, is that once you start aggressively processing an image, especially with AI-driven tools, you're no longer looking at what's actually there. You're looking at what an algorithm thinks should be there based on its training data. If you train an AI on thousands of images of spacecraft, satellites, and technological objects, then ask it to enhance a blurry dot, it might very well invent spacecraft-like details because that's what it's learned to recognize. It fills in gaps with patterns that match its training set, not necessarily with patterns that exist in reality. It's a scientific dead end wrapped in the illusion of clarity. You get images that look sharp, that show structure, that seem to reveal hidden details, but you have no way to verify whether those details are real or algorithmic hallucinations. And that uncertainty, that inability to distinguish between genuine observation and processing artifact, is exactly what makes this kind of analysis problematic. But the proliferation of these enhanced images had an unintended effect. Or maybe it was entirely intended, depending on how cynical you want to be. They muddied the waters so thoroughly that distinguishing between legitimate amateur observations and outright fabrications became nearly impossible. Within 48 hours of the ESA photo release, there were dozens of supposedly enhanced versions circulating online. Some showed metallic surfaces with specular reflections suggesting polished materials. Others depicted what looked like solar panels or antenna arrays extending from the central nucleus. A few even included what appeared to be running lights, small bright points arranged in regular patterns, or visible thruster plumes, faint streaks of light suggesting active propulsion. Most were obviously fake. Digital art created by people with too much time and too much Photoshop skill, deliberately crafted to look anomalous, shared for entertainment or attention or the simple satisfaction of fooling people. The giveaways were there if you looked. Lighting that didn't match the solar angle. Shadows falling in impossible directions. Details that were too crisp, too perfect, too obviously inserted rather than captured, but mixed in with the noise, buried under the flood of obvious hoaxes, were a handful of images that felt different, more subtle, less sensational. Images that showed just enough unusual regularity to make you wonder. Not screaming alien spacecraft with flashing lights and laser beams, just quiet anomalies, edges that shouldn't be there, brightness variations that don't match what you'd expect from a rotating irregular ice ball. And that's the genius of flooding the zone with fakes. It becomes impossible to take any of them seriously. When 99% of enhanced 3i Atlas images are obvious fabrications, the human brain starts assuming the remaining 1% are also fake, even when they might not be. It's noise-canceling signal through sheer volume. You bury potential evidence under a mountain of garbage, and anyone trying to dig through it looks like a conspiracy theorist obsessed with trash. Compare this to how amateur astronomers were treated when they captured images of Comet Lemon earlier this year. Sharp, clear photographs showing detailed tail structure, coma variations, even hints of jets emanating from the nucleus. Those images were celebrated. Astronomy publications featured them. Professional astronomers referenced them in papers. The community embraced amateur contributions as legitimate data worth analyzing. But with 3i Atlas, immediate skepticism, immediate pushback. The Dobsonian power image that started this whole controversy was dismissed within hours by self-appointed experts who've never published a peer-reviewed paper in their lives, but somehow have authoritative opinions on what processing artifacts look like. Amateur enhancements were mocked as conspiracist delusions, and the underlying message became clear. If you're an amateur astronomer, capturing images that don't match the official narrative, you're not contributing to science. You're spreading misinformation. That's a chilling shift in how the community treats citizen science. And it happened fast. Within a week of the ESA photo release, the accepted position became, amateurs aren't qualified to analyze 3i Atlas. Enhancement techniques introduce too many artifacts to trust, and anyone claiming to see structure is either incompetent or dishonest. Meanwhile, the professionals with billion-dollar equipment specifically designed for this kind of observation, still silent. 23 days since the Mars flyby. No HiRISE images, no spectroscopy, no high-resolution data that could settle the question once and for all. The contrast is stark. An amateur astronomer with a solar telescope and transparent methodology gets dismissed. But space agencies with multi-million-dollar cameras refuse to release their data. And we're supposed to just trust that everything is fine, that there's nothing unusual worth discussing, that the silence is purely bureaucratic and not at all suspicious. Here's what we know for certain. On October 3rd, multiple spacecraft captured observations of 3i Atlas. On the same day, an amateur astronomer captured an image showing potential structure. 4 days later, ESA released a fuzzy photo that showed nothing. 23 days later, NASA still hasn't released anything. And amateur attempts to enhance the available images have been drowned in a flood of obvious fakes that make serious analysis impossible. In 72 hours, 3i Atlas reaches perihelion behind the sun. No amateurs will be able to photograph it during that critical observation window. And when it reappears in mid-November, the professionals will either release their October 3rd data and prove the amateurs wrong, or they'll continue staying silent and prove that the amateurs were asking the right questions all along. The silence continues, the dismissals continue, and the countdown to perihelion continues, whether the institutions want to acknowledge it or not. On October 4th, 2025, an anonymous user on 4chan's paranormal board posted what they claimed was insider information about 3i Atlas. The post was titled simply ESA Data Leak, and it began with a credential claim that was specific enough to sound legitimate, but vague enough to maintain anonymity. I am a doctoral researcher working with the European Space Agency with continuous access to the combined observational data of 3i Atlas. What I'm about to share will get me fired if traced back, but someone needs to say this publicly. Internet leaks are a dime a dozen. Most are easily dismissed as creative fiction. elaborate role-playing exercises by people with too much time and too much imagination. Others are outright trolling, designed to seed misinformation and watch it spread for pure entertainment value. In the conspiracy theory ecosystem, 4chan occupies a special place as the source of countless hoaxes, viral myths, and deliberate disinformation campaigns that later get picked up by less discerning platforms and presented as fact. So when this post appeared, the initial reaction from most readers was skepticism. Another anonymous claim, another unprovable assertion, another thread that would get a few responses, generate some speculation, and then disappear into the archive within 24 hours, forgotten by everyone except the most dedicated conspiracy archivists. But this one was different. The level of technical detail was unsettling. The specificity was unusual. And the poster didn't make wild claims about alien invasions or secret military operations preparing for first contact. Instead, they laid out a series of observational anomalies that, if true, would fundamentally challenge our understanding of what 3i Atlas actually is without quite crossing the line into science fiction. The first anomaly, chemical impossibility. According to the post, spectroscopic analysis conducted during the October 3rd Mars flyby shows 3i Atlas is releasing approximately 100 kilograms of nickel gas per second. But the emission spectrum shows almost no iron. In normal stellar and planetary chemistry, this is impossible. Nickel and iron are inseparable twins in the cosmos. They form together in supernova explosions when massive stars die and their cores collapse, fusing lighter elements into heavier ones through rapid neutron capture. They travel together through interstellar space, condensing into the same molecular clouds, accreting into the same protoplanetary disks, appearing together in asteroids, in comets, and planets. In our own solar system, iron-nickel alloys dominate the composition of metallic asteroids. The Earth's core is primarily iron, with about 5% nickel by mass. Every iron meteorite that falls to Earth contains nickel in predictable ratios, typically between 5% and 20%. Finding abundant nickel with virtually no iron is like finding smoke without fire or shadow without light. It violates basic assumptions about how matter behaves in natural cosmic environments, about what processes create heavy elements and how they distribute through space. The post included a specific number, nickel to iron emission ratio of approximately 50:1, when typical comets show ratios closer to 1:10, favoring iron over nickel. That's not a subtle difference. That's an inversion of expected chemistry, so dramatic it would require exotic formation conditions or processes we don't currently understand. The second anomaly, thermal contradiction. The object is releasing massive amounts of gas and dust, the characteristic signature of an active comet being heated by the sun, outgassing at a rate that suggests significant sublimation of volatile ices, water, carbon dioxide, methane, all the materials that vaporize when exposed to solar radiation. But according to the post, infrared observations show the nucleus remains cold, far colder than it should be given its outgassing rate and proximity to solar radiation at the time of the Mars flyby. The poster used a vivid analogy. It's like watching someone sweat profusely in a freezer. The physics don't match the observation. If solar energy is driving massive outgassing, that energy has to be absorbed by the nucleus first, heating the surface, transferring thermal energy to subsurface ices, causing sublimation. The nucleus should be warm, possibly even hot in infrared wavelengths. But if it's staying cold while still releasing large amounts of material, where is the energy coming from? How is the outgassing being powered? One possible explanation the Post offered: internal energy source. If the object has stored energy, chemical reactions, radioactive decay, or something more exotic that could drive outgassing without external heating. But natural comets don't work that way. They're cold, inert objects until the sun warms them. They don't carry internal power sources capable of sustaining vigorous outgassing while maintaining cold surface temperatures. The third anomaly: trajectory precision. The Post referenced what Avi Loeb has been saying publicly, that 3I Atlas arrived with an orbital inclination of just 4.89 degrees relative to Earth's ecliptic plane, statistically unusual for random interstellar objects. But the 4chan poster added something Loeb didn't emphasize in his public statements. The trajectory isn't just unusual, it's a perfect straight shot from the direction of the galactic core, with no wobble, no deviation, no signs of gravitational perturbation from nearby stars during its millions or billions of years traveling through interstellar space. Objects drifting through the galaxy should show some irregularity in their paths. As they pass near other stars, even distant encounters produce small gravitational tugs that accumulate over time, causing trajectories to curve, to wobble, to deviate from straight-line motion. But according to the Post, 3I Atlas shows none of that. Its trajectory reconstructs backward as an almost perfectly straight line from the galactic core region to our solar system, as if it was aimed with precision and launched from a fixed point, not ejected randomly from another star system and then perturbed by galactic dynamics. Then came the part that elevated this from interesting speculation to something darker. The poster claimed the object fits the profile of what they called a post-biological entity. Not a natural comet, not a conventional spacecraft, something in between. Something that evolved from biological origins, but transitioned into a non-biological form. A machine intelligence, an artificial system with capabilities that blur the line between life and technology. They described it as having a 3-phase particle engine with an estimated power output of 75 megawatts, continuously transmitting an active signal at frequencies that overlap with the hydrogen line at 1420 megahertz, and in their words, probing our solar system in a manner consistent with reconnaissance rather than passive transit. 75 megawatts. To put that in perspective, a typical nuclear reactor on Earth produces about 1,000 megawatts, so we're talking about power output roughly equivalent to 7.5% of a standard nuclear power plant. Not civilization-ending energy, but substantial. More than enough to power advanced propulsion, active sensors, communication systems, whatever functions a reconnaissance probe might need. The Post concluded with a theoretical framework that, for those familiar with exotic physics, was simultaneously plausible and deeply strange. The poster suggested 3I Atlas might be a macroscopic quantum object, specifically something called a Q-ball. This is an exotic theoretical construct from particle physics, a type of non-topological soliton, a stable configuration of quantum fields that can exist at scales far larger than subatomic particles under certain conditions involving supersymmetry and scalar field theories. Q-balls are purely theoretical. No one has ever detected one. They arise from mathematical solutions to equations describing exotic particle physics beyond the standard model. But if they exist, if they're stable, they could have properties that seem impossible under normal physics. They could be incredibly dense while appearing diffuse to external observers. They could absorb and redistribute energy instantaneously across their entire structure through quantum coherence, explaining the thermal contradictions. They could even explain the nickel without iron problem if the cue ball's internal quantum state preferentially produces or concentrates certain isotopes while excluding others based on quantum numbers rather than chemical affinity. It's speculative. It's at the far edge of theoretical physics, and it requires accepting that macroscopic quantum objects can exist stably in normal space, rather than decaying immediately or existing only at extreme energy densities found in the early universe or inside neutron stars. But here's what made the post hard to dismiss: the level of technical sophistication. The references to unpublished spectroscopic data that wouldn't be available to the public. The use of scientific terminology correctly, not the garbled misuse typical of hoaxes written by people who don't understand the concepts they're referencing. And the caution in the claims, presenting this as observational data that defies explanation rather than definitive proof of alien technology. Within 18 hours, the post had been screenshot and shared across Reddit, Twitter, and dedicated UFO research forums. The conspiracy subreddit thread discussing it accumulated over 2,000 comments before moderators locked it for violating rules against unverified claims that may cause public alarm. But locking the thread didn't stop the conversation. It just moved it to other platforms, fragmenting into dozens of parallel discussions, each pulling the original post in different directions. Some focused on the chemical anomalies, debating whether nickel-rich, iron-poor compositions could arise through natural processes we haven't discovered yet. Others zeroed in on the cue ball hypothesis, pulling in physicists and graduate students to explain supersymmetric field theories and whether stable macroscopic solitons are even theoretically possible. A few started connecting it to earlier claims about 3I Atlas potentially being the source of the 1977 WOW signal, weaving together disparate threads into a grand narrative of reconnaissance probe surveying our solar system. And then came the attempts to verify or debunk the claims. Users started reaching out to ESA contacts, posting requests in academic forums, asking whether anyone with access to 3I Atlas spectroscopic data could confirm or deny the nickel-to-iron ratio. The responses were evasive or non-existent. No one with official access was willing to comment publicly. No published papers contained spectroscopic analysis from the October 3rd observations. The data simply wasn't available to check, which left everyone in the same position. An anonymous post with technical detail that's either impressively researched fiction or legitimate leaked information from someone with insider access. No way to verify, no way to debunk definitively. Just enough plausibility to keep circulating, just enough skepticism to prevent mainstream coverage. And here we are, 22 days after that post, 72 hours from Perihelion, and still no official, spectroscopic data released by any space agency. If the 4chan leak is nonsense, if the chemistry is normal, and the thermal signatures make sense, and the trajectory is just statistically unlikely, but not impossible, why hasn't ESA or NASA released the actual data to settle the question? The silence continues. The leak continues circulating, and in 72 hours, 3I Atlas will be behind the sun where we can't observe it, bathed in solar radiation. And if any part of that 4chan post is real, if there's a 75 megawatt engine, if it's not just ice and rock, perihelion is when we'd see evidence. But we won't, because we can't see behind the sun. And when the object reappears in November, any changes to its trajectory or behavior will be explained as natural cometary processes unless someone finally releases the October 3rd data that shows otherwise. The countdown continues, the questions multiply, and the answers remain locked behind institutional silence. August 15th, 1977. Ohio State University's Big Ear radio telescope detected a 72-second burst of radio energy, so unusual, so perfectly structured, so unlike anything natural sources produce, that astronomer Jerry Eman circled it on the printout and wrote one word in red pen: wow. For nearly 5 decades, that signal has remained one of the greatest mysteries in the search for extraterrestrial intelligence. It came from the direction of Sagittarius, near the constellation's densest star fields, where hundreds of thousands of stars crowd together in our view toward the galactic center. It was narrowband, focused at one specific frequency, 1420.45 by 6 megahertz, very close to the hydrogen line, the emission frequency of neutral hydrogen atoms that permeates the galaxy. And it has never repeated. Hundreds of follow-up observations, thousands of hours of listening time pointed at the same region of sky, decades of monitoring. Nothing. Just that one burst 48 years ago. And then eternal silence. Until Avi Loeb ran the numbers on 3I Atlas. He calculated where the object was on August 12, 1977, just 3 days before the WOW signal was detected. The answer? Approximately 600 astronomical units from Earth. That's 600 times the distance between Earth and the Sun, roughly 90 billion kilometers, well beyond the orbit of Neptune, out in the region where the Sun's influence starts to fade and interstellar space begins. At that distance, 3I Atlas would have been invisible to any telescope in 1977. We wouldn't have detected it. We wouldn't have known it was there. But more importantly, Loeb calculated what direction 3I Atlas was coming from at that time. The object's trajectory reconstructs backward through space, tracing the path it followed over years and decades and centuries as it approached our solar system from the depths of interstellar space. On August 12, 1977, that trajectory placed it at right ascension, 19 hours, 40 minutes. Declination, negative 19 degrees. The WOW signal came from right. Ascension, 19 hours, 25 minutes. Declination, negative 27 degrees. The two directions are separated by approximately 9 degrees. For reference, that's about 18 full moon diameters in the sky, close enough to be in the same general region, far enough that it's not an exact match. In the vastness of space with random objects coming from literally any possible direction, with the entire celestial sphere covering 41 times 253 square degrees, the probability of this alignment is about 0.6%. Not impossible. Not even particularly rare if you're just looking at a single coincidence, but 0.6%, less than 1 in 150. And when you start stacking low probability events, when you start multiplying small chances together, the compound improbability becomes harder to dismiss as random fluctuation. But Loeb didn't stop there. He asked the next logical question. If 3I Atlas sent the WOW signal from 600 astronomical units away, how powerful would the transmitter need to be? The math is straightforward. The detected intensity of the WOW signal was measured at between 54 and 212 Janskys across a 10 kHz bandwidth. A Jansky is a unit of spectral flux density used in radio astronomy, a measure of how much radio energy hits a given area per unit time per unit frequency. The exact value fluctuated during the 72-second observation window because the Big Ear telescope used a fixed antenna that swept across the sky as Earth rotated, so the signal rose as the source entered the beam, peaked, and then declined as it exited. At 600 AU distance, accounting for the inverse square law, where signal strength drops proportionally to the square of the distance, the detected intensity corresponds to a transmitter output between 0.5 gigawatt and 2 gigawatts. For reference, a typical nuclear reactor on Earth produces about 1 gigawatt of thermal energy. So we're talking about nuclear power plant levels of energy focused into a narrow radio beam, concentrated at a specific frequency, transmitted in a specific direction. Not impossible for an advanced civilization. Actually quite reasonable if you're trying to send a detectable signal across interstellar distances without wasting energy on omnidirectional broadcasting that spreads your power across the entire sphere and becomes undetectable at any useful range. There's another detail that makes the connection harder to dismiss. The WOW signal was observed at a frequency of 1420.4556 megahertz, blue shifted by approximately 10 kilometers per second toward Earth relative to the hydrogen line. Blue shift indicates the source was moving toward us. Just as light from an object moving toward you shifts to shorter wavelengths, higher frequencies, radio waves from an approaching source show the same effect. 3I Atlas is currently approaching the Sun at about 60 to 67 kilometers per second, depending on which measurement you reference. But in 1977, if this object has maneuvering capability, if it's not just following a ballistic trajectory determined by initial conditions billions of years ago, it could have been moving slower. Loeb suggests that if 3I Atlas detected habitable zone planets in our solar system through long-range observation, it might have accelerated after that detection, increasing its approach velocity from an initial slower reconnaissance speed to a faster intercept velocity, a reconnaissance pulse, a radar scan, a targeted transmission checking for signs of technological civilization before committing to a closer approach. Send a signal. Wait for a response. If you detect radio emissions, if you see modulated signals that couldn't be natural, if you find evidence of technology capable of interstellar communication, then you know the system is worth investigating further. And if you don't detect a response, maybe you slow down, maybe you alter course, maybe you decide this star system isn't interesting after all. The 1977 signal came and went in 72 seconds as the Big Ear telescope's beam swept past the source. We didn't respond. We couldn't respond. The signal wasn't recognized as potentially significant until hours or days later when Jerry Eman was reviewing the printouts. By then, the source had moved. The moment had passed. If someone was waiting for an answer, they would have received silence. Here's what makes this entire connection so frustrating. It would be trivially easy to check. Point a radio telescope at 3I Atlas. Listen at the hydrogen line frequency, around 1420 megahertz. Listen at harmonics and nearby frequencies. Monitor for any structured emissions, any modulation, any signal that doesn't match what natural sources produce. If the object is transmitting, we'll know within hours. If it's silent, the WOW signal connection is probably coincidental, just another statistical anomaly in a universe full of unlikely alignments that occasionally happen by chance. Simple test, definitive answer. Equipment exists. Multiple radio observatories around the world have the capability. The Very Large Array in New Mexico, the Green Bank Telescope in West Virginia, the Effelsberg Radio Telescope in Germany, the Parkes Observatory in Australia. SETI, the organization literally dedicated to searching for extraterrestrial intelligence, has access to all these facilities and more. Any one of them could point at 3i Atlas and listen. And yet, as Loeb noted in his latest blog post on October 7th, not a single radio telescope has reported data on 3i Atlas. The Very Large Array hasn't looked, or if they have, they haven't published results. The Arecibo telescope, which would have been ideal for this observation with its massive 300-meter dish, is gone, destroyed in 2020 when its support structure collapsed after decades of deferred maintenance. The Green Bank Telescope, the largest fully steerable radio telescope in the world, hasn't announced any monitoring efforts. Even SETI hasn't publicly stated whether they're observing this object. The silence from the radio astronomy community is deafening. Now, to be fair, radio telescope time is precious. These instruments are heavily oversubscribed, with researchers submitting proposals months or years in advance to get even a few hours of observing time. Pointing a major telescope at 3i Atlas, based on a 48-year-old unexplained signal and a statistical coincidence that might be pure chance, is not an easy sell to time allocation committees, especially when the prevailing assumption in the scientific community is that 3i Atlas is a natural comet, and any deviation from that hypothesis requires extraordinary evidence. But here's the thing. We have extraordinary claims, a trajectory with less than 1% probability for random interstellar objects, potential chemical anomalies if the 4chan leak is credible, a correlation with the WOW signal that, while not definitive, is statistically improbable enough to warrant investigation, and an object that will be at its closest approach to the Sun in 72 hours, potentially at its most active state, potentially transmitting most strongly if it has any transmission capability at all. This is the moment. If you're ever going to point a radio telescope at 3i Atlas, now is the time. Not in November when it's receding. Not in December when it's even farther away. Now, during perihelion passage, when solar energy is maximum, when the object would presumably be most active, when any signals would be strongest. And yet, as far as publicly available information shows, no one is listening. Compare this to how the radio astronomy community responded to Oumuamua, the first confirmed interstellar object detected passing through our solar system in 2017. Within weeks of its discovery, multiple radio telescopes were pointed at it. The Breakthrough Listen project, funded specifically to search for technosignatures, conducted observations across multiple frequency bands. They published their results, null detections, no anomalous signals, within months. The process was transparent. The data was shared. The scientific community engaged with the possibility that an interstellar visitor might be worth checking, even if the expected result was negative. The same thing happened with 2i Borisov in 2019, the second confirmed interstellar object. Radio observations were conducted. Results were published. The object showed no signs of artificial emissions. natural comet, as expected, but at least someone checked. 3I Atlas is the third confirmed interstellar object, and here we are, 4 months after its initial detection in July 2025, 72 hours from perihelion, and zero public radio astronomy data. Either nobody has looked, which would be a bizarre lapse in scientific curiosity given the lessons from Oumuamua and 2I Borisov, or people have looked and aren't sharing what they found. Both possibilities are troubling. If nobody's looking, it suggests a disturbing lack of interest in testing a hypothesis that could have profound implications. If people are looking but staying silent, it suggests they found something they're not ready to discuss publicly, or they found nothing and don't want to dignify conspiracy theories with negative results that will just be dismissed as cover-up. There's a third possibility, and it's the one that keeps coming up in private discussions among astronomers who are paying attention to this. Maybe someone is listening. Maybe SETI, or a national security agency with access to radio telescope time, has been monitoring 3I Atlas quietly, without public announcements, without publishing interim results, waiting to see what happens at perihelion before deciding whether to release data or keep it classified. That would make sense if you're worried about causing public alarm over something that might turn out to be nothing. Better to observe quietly, gather data, analyze it thoroughly, and only go public if there's something definitive to report. It's cautious. It's responsible. It's also exactly the kind of institutional secrecy that breeds conspiracy theories when people notice the absence of information and start filling the vacuum with speculation. So here's where we stand. 48 years ago, the WOW signal was detected from a direction 9 degrees away from where 3I Atlas was located at that time. The probability of that alignment, purely by chance, is 0.6%. The signal required gigawatt-level power to be detectable at 600 AU distance. The blue shift indicated an approaching source. And now, in 2025, an interstellar object is passing through our solar system on an anomalously precise trajectory, potentially carrying unusual chemical composition, potentially showing thermal contradictions that don't match natural comets, and nobody with a radio telescope is willing to say publicly whether they're listening. In 72 hours, 3I Atlas reaches perihelion behind the Sun. If it's transmitting, the signal would be strongest during solar approach when energy levels peak. But we won't hear it unless someone is listening. And if someone is listening, they're not telling the rest of us. The WOW signal waited 48 years for an explanation. Maybe we're about to get one. Or maybe the silence continues, and 48 years becomes 49, becomes 50, becomes another unsolved mystery that future generations will wonder about while we fail to check the obvious possibility right in front of us. 72 hours. The countdown continues. And somewhere, whether we're listening or not, 3I Atlas continues transmitting or staying silent, revealing or concealing, approaching perihelion with answers we might never receive because we didn't ask the question when we had the chance. Imagine throwing a dart at a globe from across a room while blindfolded. Now imagine that dart not only hits the globe, but lands within a few degrees of the equator. That's roughly the statistical improbability we're dealing with when we look at how 3I Atlas entered our solar system. Objects coming from interstellar space can arrive from literally any direction. They should be randomly distributed across the celestial sphere. coming in at all possible angles relative to the plane in which Earth and the other planets orbit the Sun. There's no preferred direction, no cosmic highway that channels interstellar visitors into specific trajectories. No reason why objects ejected from distant star systems should care about the orientation of our planetary system. And yet, 3I Atlas arrived with an orbital inclination of just 4.89 degrees relative to Earth's ecliptic plane, less than 5 degrees. That puts it in less than 1% of possible arrival angles, clustered so close to our planetary plane that the alignment feels deliberate rather than random. Avi Loeb has been hammering this point in every interview, every blog post, every public statement since July, when the object was first detected. The trajectory is anomalous, not just unusual, not just statistically unlikely, profoundly improbable for a random interstellar object following a ballistic path determined billions of years ago by whatever event ejected it from its parent star system. To understand why this matters, you need to think about how objects move through the galaxy. Stars in the Milky Way disk orbit the galactic center with some average velocity, about 220 kilometers per second for our Sun and neighboring stars. But they also have random motions, peculiar velocities relative to that average, moving up and down relative to the galactic plane, side to side relative to the direction of galactic rotation, like bees swarming around a hive, rather than all flying in perfect formation. That randomness means objects ejected from other star systems should arrive at our solar system from all directions with roughly equal probability. If you plot the arrival angles of interstellar visitors over time, you should get a uniform distribution across the celestial sphere. No clustering, no preferred orientations, just randomness. There's no cosmic mechanism that filters interstellar objects, that sorts them by trajectory, that sends low-inclination visitors to some star systems and high-inclination visitors to others. Gravity doesn't care about ecliptic planes. Ejection mechanisms, whether planetary encounters or stellar flybys or supernova shockwaves, don't preferentially launch objects at specific angles relative to distant solar systems they'll encounter millions of years later. And before someone suggests that maybe objects from the Milky Way disk naturally arrive at shallow angles because the disk itself is flat, Loeb addressed that too. The galactic disk is tilted about 60 degrees relative to our solar system's ecliptic plane. If 3I Atlas came from a typical star system in the galactic disk and was ejected randomly, we'd expect it to arrive at a steep angle, not a shallow one. The alignment is backwards from what galactic geometry would predict. Let's compare 3I Atlas to the only other interstellar objects we've detected. Oumuamua, discovered in October 2017, arrived with an inclination of 123 degrees, wildly tilted, coming in from above the solar system plane, passing through at a steep angle, exiting below. Exactly what you'd expect for a random interstellar visitor with no particular relationship to our planetary architecture. 2I Borisov, spotted in August 2019, had an inclination of 44 degrees, still steep, still consistent with random arrival from interstellar space. Its trajectory showed no special alignment with our ecliptic plane, no suggestion that it was aimed or guided, or anything other than a chunk of ice and rock following Newton's laws through the void. Both of those objects behaved exactly as expected for natural interstellar visitors. Random inclinations, no clustering, no patterns that would make you think twice about their origins. 3i Atlas is the outlier, the anomaly, the one that doesn't fit the pattern. And it's not just the inclination, it's the precision of the trajectory when you reconstruct it backward through time. According to the 4chan leak, which remains unverified but includes details that suggest insider knowledge, the trajectory of 3i Atlas traces back as an almost perfectly straight line from the galactic core region to our solar system. No wobble, no deviation, no signs of gravitational perturbation from nearby stars during its journey through interstellar space. That's unusual. Objects drifting through the galaxy should show some irregularity in their paths. As they pass near other stars, even encounters at distances of thousands of astronomical units produce small gravitational tugs. Those tugs accumulate over time, causing trajectories to curve, to wobble, to deviate from straight-line motion. It's a game of cosmic billiards where every near miss with another star slightly alters the path. And over millions of years, those alterations become significant. But 3i Atlas, if the leaked data is accurate, shows minimal perturbation. Its path reconstructs as nearly straight, as if it was launched from a specific location with a specific velocity and then traveled through space without significant interference. That's what you'd expect from an aimed trajectory, from something that compensates for gravitational encounters by making small course corrections from a guided object rather than a passive drifter. Loeb calculated the probability of this alignment. The 4.89 degree inclination combined with arrival from the galactic core direction, assuming random arrival angles. Less than 1% chance, maybe as low as 0.5%, depending on how you model the galactic velocity distribution and account for observational biases. Some colleagues pushed back, suggesting his statistics were too conservative. Maybe the true probability is closer to 5% or 10% when you account for selection effects, for the fact that we're more likely to detect objects passing close to Earth, and those objects necessarily have at least some component of motion aligned with our orbital plane. Otherwise, they'd miss us entirely, and we'd never see them. Fine. Even at 10%, you're still looking at something that should only happen once in every 10 interstellar objects we detect. And we've only detected 3. The odds of the third one being the rare exception, rather than the rule, are not in favor of coincidence. Now layer that on top of everything else. The WOW signal alignment, also less than 1% probability. The chemical anomalies with nickel-rich, iron-poor composition that violate standard cosmic chemistry. The thermal contradictions where massive outgassing occurs without corresponding surface heating. The missing HiRISE images from NASA, despite 23 days since the Mars flyby. The government shutdown that started 2 days before the best observational opportunity. The absence of public radio telescope data, despite the obvious test to perform. Any single one of these things could be explained away. Coincidence, measurement error, bureaucratic incompetence, natural processes we don't fully understand yet. But when you start stacking anomalies, when you start multiplying small probabilities together, the compound improbability becomes harder to dismiss. There's a principle in statistics called the prosecutor's fallacy. It's the mistake of treating multiple independent low-probability events as if they're related when they're actually just random coincidences that happen to cluster together. If you flip a coin enough times, eventually you'll get 10 heads in a row. it doesn't mean the coin is rigged. It just means you flipped it enough times for unlikely sequences to occur. Skeptics will argue that's what we're seeing with 3I Atlas, a natural comet that happens to have several unusual but ultimately explainable properties that coincidentally appear together in the same object. Unlikely, sure, but not impossible. And in a universe with billions of stars and trillions of comets, unlikely things happen all the time. They have to. The probability of something unlikely happening somewhere is actually quite high, even if the probability of any specific unlikely thing happening at a specific time and place is vanishingly small. Fair argument, statistically sound. And if this were purely an academic exercise, if we were just analyzing probabilities on paper with no consequences for getting it wrong, that skepticism would be the appropriate default position. But this isn't purely academic. This is an object currently approaching perihelion, 72 hours from its closest pass by the Sun, potentially about to demonstrate whether it's natural ice and rock or something else entirely. And the consequences of being wrong, of dismissing anomalies as coincidence when they're actually evidence of something unprecedented, are not symmetric. If we treat 3I Atlas as potentially technological, devote resources to observing it carefully, point radio telescopes at it, analyze every data point, and it turns out to be just a comet, we've wasted some telescope time and looked silly. Embarrassing, but not catastrophic. We overinterpreted coincidences and got egg on our faces. Science corrects itself. We move on. But if we treat it as just another comet, ignore the anomalies, don't bother with radio observations, and it turns out to be technological, we've missed the most important observational opportunity in human history. We'll have let an interstellar probe pass through our solar system while we were too busy arguing about statistics to actually check whether it's transmitting. The asymmetry of consequences matters. The cost of false positive is low. The cost of false negative is potentially catastrophic, not in terms of physical danger necessarily, but in terms of missed knowledge, lost opportunities, failure to recognize first contact when it's staring us in the face. And that's why the 4.89-degree trajectory matters. Not because it's definitive proof of anything, but because it's one more data point in a growing pattern of anomalies that, taken together, suggests this object deserves more scrutiny than it's receiving. Oumuamua had unusual features too. Its elongated shape, its non-gravitational acceleration as it left the solar system, suggesting outgassing but without detectable cometary activity. Those anomalies sparked intense debate. Papers were published. Observations were conducted. Radio telescopes listened. The scientific community engaged seriously with the possibility that something unusual was happening, even though the consensus ultimately landed on natural explanations. 3I Atlas has more anomalies than Oumuamua, more statistical red flags, more unexplained observations, and yet the institutional response has been muted, minimal, almost dismissive. The ESA released one set of fuzzy images and went quiet. NASA blamed a government shutdown and provided nothing. Radio astronomers haven't published observations. The data from October 3rd remains locked away. Why the different response? Why did Oumuamua get intense scrutiny while 3I Atlas gets silence? Maybe it's fatigue. Maybe after Oumuamua turned out to be natural despite the unusual features, the community decided that every weird interstellar object doesn't deserve the full treatment. Maybe the lesson learned was anomalies don't mean aliens, and now there's resistance to repeating that cycle. Or maybe it's something else. Maybe the observations from October 3rd showed something that doesn't fit easily into either category, natural or technological. Maybe the data is ambiguous enough that releasing it without proper context would cause confusion or panic. Maybe institutions are being cautious because they learned from Oumuamua that premature speculation creates problems. Or maybe, and this is the possibility that keeps surfacing in private conversations, maybe someone knows exactly what 3i Atlas is, and they're not ready to tell the rest of us yet. The trajectory that shouldn't exist. That's what we're looking at. An object arriving from interstellar space with an alignment so precise it falls into the statistical tail of random expectations. Not impossible, just profoundly unlikely. The kind of unlikely that makes you check your calculations twice. The kind that makes you wonder whether the assumptions underlying those probability calculations are actually valid. In 72 hours, 3i Atlas reaches Perihelion. If it's following a natural ballistic trajectory, solar gravity will bend its path in predictable ways. We can calculate the deflection. We can forecast where it should be when it emerges from behind the sun in mid-November. And when it reappears, we'll measure its actual position and compare it to predictions. If the trajectory matches, if there's no deviation beyond what gravitational perturbations from the sun and planets would produce, then the unusual inclination becomes coincidence. Low probability, but not impossible. Just one of those things that happens occasionally in a big universe. But if there's deviation, if the trajectory changes in ways that can't be explained by gravity and solar radiation pressure and outgassing thrust, then the 4.89-degree alignment becomes evidence. Evidence of capability, evidence of guidance, evidence that this object didn't arrive here by accident, but by design. 72 hours. That's all the time left before perihelion, before the crucial moment happens behind the sun where we can't observe it, before 3i Atlas either follows the path natural objects follow or demonstrates that it's following a path of its own choosing. The numbers don't lie. The trajectory is anomalous. And the silence about what that might mean grows louder with every passing hour. 72 hours. That's the window. Perihelion, closest approach to the sun, is the true moment of reckoning for any comet. And for 3i Atlas, it has become an orbital cliffhanger with no direct view for observers on Earth. To understand why this moment matters, we need to consider what actually happens to a standard comet during such a close encounter with the sun. At 0.76 AU, or about 100 to 14 million kilometers from the sun, 3i Atlas will be subject to a level of solar heating about 1.7 times the energy Earth receives. For an object made of ices, water, carbon dioxide, methane, ammonia, and dust and stone, this typically triggers a spectacular increase in activity. Frozen volatiles, locked for eons in the deep cold of interstellar space, begin to sublimate directly into gas. The surface crackles and vents. Pressure builds beneath crusts of dust until they blow out new geysers. The coma blooms, an expanding shroud of gas and dust, tens of thousands of kilometers wide, growing in brightness, sometimes forming multiple tails. This is the moment comet watchers wait for, the transformation of a dark, dormant rock moving through deep space into a living, luminous beacon, visible across the solar system. But not all comets survive perihelion. For many, this is the moment of greatest peril. The sudden thermal energy can create intense stress as ice vaporizes from within or beneath the surface, shattering fragile crusts or breaking apart bodies already weakened by past journeys. Comet 73P Schwarzmann-Wachmann 3 is perhaps a modern textbook case. In 2006, it fragmented into dozens of pieces as it approached perihelion, creating a string of cometary pearls across the sky, each, briefly, its own little world of outgassing and decay. Comet Linear C2000 WM1 disintegrated entirely under perihelion's hammer, leaving behind a cloud of dust and vapor mourned by astronomers tracking its progress. ISON, once hyped as the comet of the century, flew to within 1.2 million kilometers of the Sun in 2013, only to be utterly destroyed, dissolved by the heat and tidal forces at the very moment millions of eyes were waiting for it to shine brightest. For 3I Atlas, the solar environment at 0.76 AU is less severe than ISON's suicidal plunge, but the stress will be significant. Calculations suggest the surface will reach several hundred Kelvin, high enough for water ice, carbon monoxide, and carbon dioxide all to sublimate rapidly. Small comets with low tensile strength, those that are more dirty snowball than solid rock, are most at risk of breakup. Gas vents create jets, which can spin or torque the nucleus if venting is asymmetrical, sometimes leading to rotational instability and breakup. If internal voids or fractures exist, pressure can build until seams burst open, splitting the nucleus with sudden violence. Traditionally, astronomers would expect a natural comet at this distance to show a pronounced brightening curve, a sharp increase in magnitude as new volatiles erupt. We'd see a luminous tail extending, sometimes huge jumps in brightness measured over just hours or days. If fragmentation is occurring, telescopic images can reveal multiple nuclei, clouds of debris trailing behind, chaotic jets, or structures in the tail that look like kinks, knots, or disconnection events as magnetic fields from the solar wind buffet the newly exposed ices. And here's the catch. For 3I Atlas, all of this happens behind a sun. We will be left with before and after. What's seen in November, after solar conjunction, will be crucial. If the object emerges substantially brighter, we'll know it survived perihelion and release significant volatiles. If it's fainter or appears as several fragments, fragmentation will have occurred. If it can't be found at all, total disintegration is a real possibility, matching what's been documented from past perihelion fatalities in cometary history. But there's a twist. Since July, 3I Atlas has already shown less than expected brightening for its approach to the Sun. Its brightness curve and activity haven't matched standard cometary models, fueling suspicions in both professional and amateur circles. Dozens of observers have charted the object's photometry and failed to see the magnitude jumps typical of an icy nucleus venting gas. Is this a sign of low volatile content, an unusually cohesive interior, or something else, compositionally or structurally unique? A troubling layer. If those 4chan leak claims are real, if 3I Atlas is a metallic-rich body, or possesses internal energy sources that drive outgassing independently of solar heating, then perihelion may play out very differently. The nucleus could maintain unusual composure, remain cold despite violent gas loss, or even survive unscathed, where every expectation suggests partial disintegration. This is the moment for experts to deploy models and analogies, but the absence of real-time spectroscopic data, the withholding of high-resolution imagery, and the ongoing silence from multiple space agencies means we won't even see the intermediate states of this cosmic trial. We'll be left to guess from indirect evidence, before and after shots, a slow fade or dramatic disappearance, and the narrative that takes shape from official channels months later. Avi Loeb is explicit. If it's a natural comet, perihelion will be the point of ultimate stress. We should see an explosive event and subsequent debris. The alternative? If it's technological, perihelion could serve as a gravitational assist or even be a natural screen, concealing maneuvers, probe releases, or a deliberate alteration of trajectory at the one moment when no prying eyes can watch from Earth. In summary, perihelion is nature's harshest test for any comet. Chemistry, structure, orbit, all are revealed or rewritten by the sun's relentless energy at closest approach. For 3I Atlas, this test plays out beyond our sightline. When it emerges again, whatever shape, brightness, or path it takes may close the case or blow it wide open. And yet, as the clock runs down, the silence grows deeper. The comet approaches its fate, and so does our trust in what we're being told. 3 days until the sun either makes or unmakes a cosmic mystery just outside our reach. Mid-November 2025. Mark that time frame, because sometime between November 10th and November 20th, depending on exactly when solar conjunction ends and atmospheric seeing conditions cooperate, 3I Atlas will emerge from behind the sun and become visible again from Earth. Ground-based telescopes will be able to track it once more. Amateur astronomers will point their equipment at the coordinates. Professional observatories will resume monitoring, and we'll finally see what perihelion did to this object during the days it spent hidden from our view behind 150 million kilometers of nuclear fire. This is the moment of revelation. Either we'll see fragments of a shattered comet drifting through space, confirming everything mainstream science predicted, or we'll see an intact object on a potentially altered trajectory, forcing us to confront questions we're not prepared to answer. But here's the frustrating part. Even when 3I Atlas reappears, even when telescopes lock onto it again, we won't immediately know what happened. The European Space Agency has announced that their JUICE spacecraft, the Jupiter Icy Moons Explorer, currently en route to the Jovian system, will observe 3I Atlas between November 2nd and November 25th using various instruments. JUICE carries cameras, spectrometers, and sensors capable of capturing data that could finally settle some of the questions about composition, structure, and behavior. But the data won't be available until February 2026, 3 months between observation and data release. Communication delays as JUICE transmits information back to Earth across hundreds of millions of kilometers. Processing time as engineers and scientists validate the data, calibrate the instruments, remove artifacts, and prepare results for publication. Standard procedures, normal timelines for deep space missions, which means we'll watch 3I Atlas in November, but won't know what we saw until February. We'll see whether it's intact or fragmented. We'll measure its brightness and track its position. But the detailed analysis, the spectroscopy that reveals composition, the high-resolution imaging that shows surface features, all of that remains locked away for months. Think about that timing. Perihelion happens, October 29th. Reappearance mid-November. JUICE observations November 2nd through 25th. Data release February 2026. That's 4 months between the critical observation window and when we finally get answers. 4 months of uncertainty. 4 months of speculation. 4 months where the conversation will be dominated not by data, but by interpretation of limited observations, by amateur analysis filling the void left by institutional silence, by conspiracy theories growing in the absence of official information. And that's assuming JUICE data gets released in February, as promised. Assuming there are no additional delays. Assuming the results are made public, rather than classified or withheld for further review, or held for publication in peer-reviewed journals that might take additional months to process submissions. Meanwhile, ground-based telescopes will be watching, and what they'll be looking for in November is straightforward: trajectory analysis. Has 3I Atlas's path changed in ways that can't be explained by gravitational forces alone? The orbital elements will be recalculated as soon as enough positional measurements accumulate. Within days of reappearance, astronomers will know whether the object is following its predicted post-perihelion trajectory or whether something has changed. If it's a natural comet, the path should be predictable. Solar gravity will have deflected the trajectory in calculable ways. Outgassing might produce small, non-gravitational accelerations as jets of gas create thrust, pushing the nucleus slightly off course. We've seen this with other comets. It's well understood. The deviations are small, measurable, and follow patterns that match cometary physics. But if the trajectory shows changes that can't be explained by gravity and standard outgassing, if the object is moving in ways that suggest active course correction or maneuvering capability, then we're in unprecedented territory. That would be the smoking gun. The definitive evidence that 3I Atlas is not just a passive chunk of ice and rock, but something capable of altering its path through space. Avi Loeb has been explicit about what this means. In his October 3rd blog post, he wrote, "If 3I Atlas will maneuver towards Earth when it reappears on the other side of the sun, the financial markets may crash." That's not hyperbole. That's not fear-mongering. That's a sober assessment of what happens when existential uncertainty enters global consciousness all at once. Markets respond to predictability. Investors make decisions based on assumptions about how the world works, about what risks exist, about what futures are possible. The entire structure of modern economics rests on shared beliefs about stability, continuity, and the absence of sudden paradigm-breaking events that invalidate all existing models. If 3I Atlas demonstrates technological capability, if it shows evidence of maneuvering toward Earth or toward any destination that suggests intentional navigation, those shared beliefs collapse instantly, not gradually, not over years as scientific consensus builds and society adjusts. Instantly, the moment credible observations confirm active course correction. Every assumption about humanity's place in the cosmos gets challenged simultaneously. Stock markets would experience volatility unlike anything in modern history. Not because an interstellar object poses immediate physical danger. 0.76 AU perihelion means it's not on a collision course with Earth, but because uncertainty itself becomes unbearable when the stakes are existential. What does it want? Where is it going? What happens if it changes course again? What does this mean for defense spending, space policy, resource allocation, technological development, everything? Governments would face unprecedented pressure to provide answers they don't have. Space agencies would be forced to disclose data they've been withholding. Scientific institutions would have to explain why they didn't take the anomalies seriously earlier, why they dismissed amateur observations, why they stayed silent when questions were being asked. And that's just if 3I Atlas maneuvers toward Earth. If it maneuvers away, if it demonstrates capability but shows no interest in our planet, the implications are almost as profound. It means we've been observed, surveyed, assessed, and either found lacking or simply cataloged as another inhabited world in a galaxy full of them. The psychological impact of that realization, the shift from "we might be alone" to "we're definitely not alone, and something just flew through our solar system taking notes," that's civilization altering. But there's another scenario, perhaps more likely, that Loeb hasn't emphasized as much in public statements. What if 3I Atlas doesn't maneuver at all? What if it emerges from perihelion on exactly the trajectory gravitational models predict, showing no evidence of active control, looking every bit like a natural comet that happens to have unusual composition and a statistically unlikely path? That doesn't answer the questions. It just defers them, because the anomalies remain. The 4.89-degree inclination doesn't become less improbable. The wow signal correlation doesn't disappear. The chemical inconsistencies, if they're real, still violate expectations. The institutional silence about October 3rd observations still demands explanation. All of it stays on the table, unresolved, waiting for someone to provide data that either confirms natural processes or demonstrates technological origin. And here's where the Galileo project becomes crucial. Loeb's 3 observatories in Massachusetts, Pennsylvania, and Nevada will be operating at maximum capacity throughout November. High-resolution cameras, infrared sensors, radio receivers, all designed specifically to detect anomalous aerial phenomena, to capture data on objects that don't behave according to conventional physics, to provide evidence where official channels stay silent. If 3I Atlas releases probes after perihelion, if there's enhanced UAP activity correlated with its emergence from solar conjunction, if something enters Earth's atmosphere that shouldn't be there, the Galileo instruments might catch it. Might. Operative word. Because 3 observatories covering limited sky, monitoring specific wavelengths, can only see what falls within their field of view. If something happens over the Pacific Ocean, or the Sahara Desert, or Antarctica, or anywhere else not covered by those observation zones, it slips through undetected. It's a net with large holes trying to catch something that, if it's technological, probably has the capability to avoid detection if it wants to. But it's the best we have outside official channels. It's the civilian effort, the transparent initiative, the publicly stated commitment to check for what institutions won't confirm or deny they're looking for. Loeb has stated publicly that Galileo project will release any significant findings immediately, not months later, not after peer review, but as soon as verification is complete. If they detect something anomalous in November, we'll know. Not in February. Not after committees review and agencies approve and publication pipelines process. We'll know. That's the value of independent observation networks. That's why amateur astronomers matter. That's why citizen science fills gaps that institutions leave open. Because when trust erodes, when silence replaces transparency, when people start suspecting that important information is being withheld, having alternative sources becomes essential. So here's the November timeline. Sometime between the 10th and 20th, 3I Atlas reappears. Within days, trajectory analysis will determine if its path has changed. Within weeks, brightness measurements will reveal whether it survived perihelion intact or fragmented. JUICE will be observing from November 2nd through 25th, but we won't see that data until February 2026. Galileo Project will be monitoring for anomalous activity, and if they find anything, we'll know immediately. And through all of this, the questions accumulate. What did NASA's HiRISE camera actually capture on October 3rd? Why haven't China or the UAE released their observations from the Mars flyby? What did radio telescopes detect if anyone was actually listening? What's in the spectroscopic data that hasn't been published? What does ESA know that they're not saying? November doesn't answer those questions. November just adds new observations to the pile of unexplained data. And unless institutions start being transparent, unless the October 3rd observations finally get released, unless someone breaks the coordinated silence, we'll be left with more evidence and less certainty than when this all started. 3 days until perihelion. 3 weeks until reappearance. 3 months until JUICE data. And through it all, the silence continues, punctuated only by the slow accumulation of observations that institutions won't acknowledge and questions they won't answer. The countdown ticks down. The comet approaches its hidden rendezvous with solar fire. And we wait, knowing that when it reappears, everything changes, or nothing does. And either outcome leaves us with more mysteries than we started with. October 26th, 2025. Day 26 of the United States government shutdown. Over 15,000 NASA employees remain furloughed. The agency's website hasn't been meaningfully updated in nearly 4 weeks. Public communications have ceased. Press releases that would normally follow significant observational events remain unwritten, unapproved, unpublished. The Mars Reconnaissance Orbiter, equipped with the most powerful camera ever sent to another planet, captured high-resolution images of 3I Atlas on October 3rd. 23 days later, those images remain unreleased, locked behind bureaucratic paralysis that shows no signs of resolution. The shutdown is real. The furloughs are documented. The congressional deadlock preventing budget approval is a matter of public record. All of that is verifiable. But it doesn't explain everything, because NASA isn't the only space agency that observed 3I Atlas during the October 3rd Mars flyby. And the others don't have the excuse of domestic political dysfunction to justify their silence. The European Space Agency released images on October 7th, 4 days after the flyby. Fuzzy photos from the ExoMars Trace Gas Orbiter showing a white dot moving against stars. No detail, no structure, just confirmation that the object exists and moves. Since then, nothing. No spectroscopic analysis, no follow-up observations, no additional commentary beyond the initial 4-sentence statement acknowledging the capture. ESA isn't affected by the US government shutdown. Their operations continue normally. Their scientists are working. Their instruments are functional. And yet, radio silence. China's Tianwen-1 orbiter was positioned to observe 3I Atlas with its Mars orbiter camera. The Chinese space program operates completely independently of American politics. They don't shut down when the US government does. They don't coordinate observation schedules with NASA. They don't wait for approval from Washington before releasing data. And yet, as of October 26th, 23 days after the flyby, China hasn't released a single image. Not a fuzzy dot like ESA. Not even an acknowledgement that they attempted observations. Complete silence. The United Arab Emirates Hope Orbiter, equipped with the Emirates Exploration Imager, had a clear observational window during the October 3rd flyby. The UAE space program is small but capable, and they've been remarkably forthcoming with data from their Mars mission since arrival in 2021. They've published images regularly. They've shared scientific findings. They've been transparent about both successes and technical challenges. But on 3i Atlas, nothing. No images, no statements, no acknowledgement that the object even passed through their observational field of view. 4 space agencies, 4 sovereign nations with completely separate bureaucracies, political systems, funding mechanisms, and priorities. NASA blames a government shutdown. But what's China's excuse? What's the UAE's excuse? What's ESA's excuse for releasing one set of inadequate images and then going silent for 3 weeks? The pattern is undeniable. Multiple governments, multiple institutions, all simultaneously unable or unwilling to release comprehensive observational data on the most scientifically significant interstellar object to visit our solar system since 2I Borisov in 2019. This isn't normal. This isn't how space agencies typically operate. When something interesting happens, when rare observational opportunities arise, when data that could advance our understanding of the cosmos becomes available, institutions compete to publish first, to claim credit, to demonstrate their capabilities and justify their budgets. But with 3i Atlas, the opposite has happened. A coordinated withdrawal, a collective decision, whether explicit or implicit, to minimize public engagement, to downplay anomalies, to avoid speculation, to wait until what? Until someone decides it's safe to talk? Until the object has passed and public interest has faded? Until whatever was observed can be packaged into a narrative that doesn't raise uncomfortable questions? Let's talk about what else hasn't happened. Radio telescope observations. As discussed in Chapter 5, pointing a radio telescope at 3i Atlas to check for transmissions would be trivially easy. The hydrogen line frequency at 1420 MHz is well known. The equipment exists at multiple facilities around the world. The observation would take hours, not months, and the result would be definitive. Either the object is transmitting structured signals, or it's not. Simple test, clear answer. And yet, as of October 26th, not a single radio telescope has publicly reported observations of 3i Atlas. The Very Large Array in New Mexico hasn't published results. The Green Bank Telescope in West Virginia hasn't announced monitoring efforts. The Effelsberg Radio Telescope in Germany hasn't released data. The Parkes Observatory in Australia hasn't shared findings. SETI, the organization literally dedicated to searching for extraterrestrial intelligence, hasn't publicly stated whether they're observing this object. Either nobody has looked, which would be a bizarre lapse in scientific curiosity given the precedent set by Oumuamua and 2I Borisov, where radio observations were conducted promptly, or people have looked and aren't sharing results. Both possibilities are troubling. If nobody's looking, It suggests institutional fatigue, a decision that every anomalous interstellar object doesn't deserve full scrutiny. If people are looking but staying silent, it suggests they've either found nothing and don't want to dignify conspiracy theories with negative results, or they've found something they're not ready to discuss publicly. There's a third possibility that keeps surfacing in private conversations among astronomers paying attention to this situation. Maybe someone is listening. Maybe SETI, or a national security agency with access to radio telescope time, has been monitoring 3I Atlas quietly, without public announcements, without interim reports, waiting to see what happens at Perihelion before deciding whether to release data or keep it classified. That would make sense if you're worried about causing public alarm over something that might turn out to be nothing. It's cautious. It's responsible. It's also exactly the kind of institutional secrecy that breeds conspiracy theories when people notice the absence of information and start filling the vacuum with speculation. Now let's talk about what's been happening on social media, because the institutional silence has created space for something unexpected. Distributed citizen observation networks coordinating in real time without waiting for official permission or guidance. On Reddit, the ER Astronomy and r/shar Space subreddits have mega-threads tracking 3I Atlas with thousands of comments analyzing available data, sharing amateur observations, debating interpretations. Moderators have struggled to balance allowing discussion against enforcing rules about unverified claims and speculative content. Some threads get locked. Some posts get removed. Users complain about censorship. Moderators respond that they're just maintaining subreddit quality standards. The tension between open discussion and platform moderation has never been more visible. On Discord, dedicated astronomy servers have channels specifically for 3I Atlas coordination. Amateur observers share equipment specs, observation schedules, processing techniques. When the object reappears in November, these networks will be ready to capture images within hours, to track position changes, to measure brightness, to create a distributed observational database that doesn't depend on institutions releasing data months later. On X, formerly Twitter, the hashtag #3iAtlas trends sporadically despite algorithm suppression that multiple users have documented. Posts that would normally reach tens of thousands of people plateau at hundreds of views. Engagement metrics that should trigger broader distribution don't. It's not overt censorship, it's algorithmic dampening. Quiet enough to be deniable, but aggressive enough to be effective at limiting reach. Content creators on YouTube have reported similar patterns. Videos analyzing 3I Atlas anomalies receive demonetization notices. The stated reasons vary. Some are flagged for discussing sensitive topics without proper context. Others get categorized as potentially misleading content about scientific matters. A few receive the vague but ominous label, content that may not be suitable for all advertisers. The pattern is clear. You can make a video saying 3I Atlas is definitely just a comet, and mainstream science has it figured out. That's fine. Monetized. Promoted. But suggest there might be anomalies worth investigating? Suddenly, your video becomes advertiser unfriendly. This creates a chilling effect, not through overt censorship, but through economic pressure. If discussing certain topics costs you revenue, If platforms algorithmically suppress content that asks uncomfortable questions, most creators will self-censor. They'll stick to safe topics. They'll avoid speculation. They'll wait for official statements before commenting. And the conversation narrows, not because anyone explicitly ordered it narrowed, but because the incentive structure punishes deviation from accepted narratives. But here's what platforms didn't anticipate. The suppression itself becomes part of the story. Every removed Reddit post generates screenshots that circulate elsewhere. Every demonetized YouTube video gets mentioned in comments and Discord servers. Every instance of algorithmic dampening on X gets documented and shared. The attempt to manage the conversation amplifies suspicion that there's something worth managing, something worth suppressing, something institutions don't want widely discussed. And that suspicion, whether justified or not, fundamentally undermines trust. Because once people start believing that information is being controlled, that platforms are coordinating to limit discussion, that institutions are hiding data, it becomes nearly impossible to restore credibility, even if the underlying facts are entirely innocuous. The irony is profound. If 3I Atlas is just a natural comet with unusual but ultimately explainable properties, the institutional silence and platform suppression are creating exactly the kind of conspiratorial thinking they presumably want to avoid. If it's something more, if there are legitimate anomalies that deserve serious investigation, the silence prevents that investigation from happening transparently, forcing it into corners of the internet where signal and noise become indistinguishable. So here we are, 26 days into a government shutdown that has paralyzed NASA at the worst possible moment. 23 days since the Mars flyby, with no HiRISE images released. 3 weeks of silence from ESA beyond one set of inadequate photos. 0 public statements from China or the UAE about their observations. No published radio telescope data, despite obvious reasons to check for transmissions. And a pattern of social media suppression that's subtle enough to deny, but pervasive enough that hundreds of users have documented similar experiences. In 72 hours, 3I Atlas reaches perihelion behind the sun. Everything that defines this object, everything that determines whether it's natural or technological, ice or something else, passive or actively maneuvering, all of it happens during the window when Earth-based observation is impossible. We'll see the result when it reappears in mid-November. But we won't see the process. We won't watch it happen. We'll only know what institutions choose to tell us afterward. And based on the last 26 days, based on the coordinated silence across multiple space agencies, based on the absence of radio observations, based on the platform suppression of discussions that ask uncomfortable questions, how much trust should we place in whatever narrative emerges? The amateur community has an answer. None. They're building their own observation networks. They're sharing data peer-to-peer. They're preparing to document 3I Atlas's November reappearance independently of whatever institutions do or don't release. Because when trust erodes, when silence replaces transparency, when every attempt to discuss anomalies gets dampened or dismissed or demonetized, people create alternative systems. Maybe those systems produce better data. Maybe they just produce more noise. But they exist now. They're coordinated. And when 3I Atlas emerges from behind the sun in November, thousands of telescopes operated by individuals who don't wait for institutional permission will be watching. The silence continues. The suppression continues. The institutional coordination continues. And the countdown to perihelion continues, indifferent to human politics, platform algorithms, or the questions no one in authority seems willing to answer. 72 hours remain. Then the sun becomes both witness and screen, observer and obstacle, the source of energy that will test whether 3I Atlas behaves as natural comets do, or whether it demonstrates something we're not supposed to talk about yet. The comet approaches, the silence deepens, and we wait, knowing that answers may come in November or may not come at all, and that either outcome confirms what many have already concluded. We're not being told everything, and maybe we never will be. The countdown ends in 72 hours. On October 29th, 2025, at approximately 6 mile AM UTC, 3I Atlas will reach perihelion at 0.76 astronomical units from the sun, hidden behind our star from every telescope on Earth, bathed in solar radiation that will either shatter it like so many comets before, or reveal its true nature in ways we won't immediately understand. And then the waiting begins. Mid-November. That's when the object emerges from solar conjunction and becomes visible again. Ground-based telescopes will reacquire it. Amateur observers will point their equipment at updated coordinates. Professional observatories will resume tracking. And within days, within hours potentially, we'll have preliminary answers to questions that have been building since July, when this object was first detected entering our solar system on an impossibly precise trajectory. But here's what we need to understand about those answers. They won't come from institutions. Not immediately, not transparently. The pattern of the last 26 days, the coordinated silence across multiple space agencies, the absence of October 3rd data despite 23 days passing, the lack of radio telescope observations despite trivial effort required, all of it suggests that official channels have chosen a different timeline than public curiosity demands. NASA's HiRISE images, if they're ever released, will come months after capture. ESA's spectroscopic data from the Mars flyby remains unpublished with no announced release date. JUICE spacecraft observations, scheduled for November 2nd through 25th, won't be processed and shared until February 2026, 3 full months after the observations occur. China and the UAE haven't even acknowledged they attempted observations, let alone committed to data release schedules. So the first real answers, the immediate determinations about what 3I Atlas looks like post-perihelion, will come from the Distributed Amateur Observation Network. From Reddit coordination threads, where observers share real-time position measurements. From Discord servers, where image processing techniques get refined and applied to fresh captures. From X posts, where brightness estimates accumulate and trajectory deviations get calculated before any official statement emerges. That's the new reality. Institutions move slowly. Peer review takes months. Publication pipelines add more months. Approval processes within government agencies add even more delay. But individuals with telescopes, with cameras, with processing software, with internet connections, they move at the speed of observation plus upload. Hours after 3I Atlas reappears, we'll have images. Days after, we'll have trajectory analysis. Weeks after, we'll have enough data points to determine if anything unusual happened during perihelion passage. And that amateur data will force institutions to respond. Because once information exists in the public domain, once observations are being shared and analyzed outside official channels, the strategy of silence becomes untenable. Agencies will have to either confirm the amateur findings, which validates citizen science and undermines institutional gatekeeping, or contradict them, which requires releasing their own data and explaining discrepancies. Either way, transparency increases, not because institutions chose it, because they were forced into it by distributed networks that don't wait for permission. Now, let's talk about what those November observations will actually tell us. There are 3 broad categories of outcomes, each with different implications. Outcome 1. Natural fragmentation. 3I Atlas emerges as multiple pieces, a debris field of fragments following similar but slightly diverging trajectories. Brightness is distributed across several objects rather than concentrated in one nucleus. The pattern matches historical comet breakups. This is what you'd expect if thermal stress and internal pressure during perihelion passage exceeded structural limits and the nucleus split apart. If this happens, the natural comet hypothesis is essentially confirmed. Unusual chemistry? Maybe, but natural. Unlikely trajectory? Coincidence. Wow signal correlation? Random alignment. All the anomalies become explainable within conventional frameworks because the object behaved exactly as natural comets do when subjected to solar stress. Case closed. Conspiracy theories debunked. Institutions vindicated, except not entirely. Because the questions about why data wasn't released earlier, why radio telescopes didn't observe, why multiple space agencies coordinated silence, those questions remain. The behavior of institutions doesn't get explained just because the object turns out to be natural. Trust, once eroded, doesn't automatically restore just because one hypothesis gets validated. Outcome 2. Intact survival with normal trajectory. 3I Atlas emerges as a single object, nucleus intact, following the predicted post-perihelion trajectory, with deviations explainable by gravity and standard outgassing thrust. Brightness is consistent with models. Spectroscopic observations, when eventually released, show composition that makes sense for interstellar comets. No fragmentation. No anomalous trajectory changes. Just a comet that survived perihelion and continues on its hyperbolic path out of the solar system. This is the ambiguous outcome. It doesn't definitively prove anything. The unusual trajectory remains unexplained, but not impossible. The chemical anomalies, if real, remain puzzling but potentially natural. The wow signal correlation stays coincidental, but statistically unlikely. We're left exactly where we started, suspended between probably natural and possibly technological, with insufficient evidence to conclusively determine which. And in this scenario, the institutional silence becomes even more frustrating. Because if the object is behaving normally, if there's nothing particularly unusual happening, why the reluctance to share data? Why the coordinated non-response? Why treat this object differently than Oumuamua or 2I Borisov, which both received prompt scientific attention and data release? The absence of explanation becomes the anomaly. The silence itself becomes evidence that something about 3I Atlas made institutions cautious in ways previous interstellar visitors didn't. Outcome 3. Anomalous trajectory or behavior. 3I Atlas emerges intact, but trajectory analysis shows deviations that can't be explained by gravitational perturbations and standard cometary physics. The path has changed. Not dramatically, not in ways that suggest immediate threat, but measurably, detectably, in manners consistent with active maneuvering or course correction. This is the scenario Avi Loeb warned about. This is when everything changes. Because trajectory deviation beyond natural explanations is the definitive test. You can debate chemical composition. You can argue about statistical probabilities. You can dismiss amateur observations as processing artifacts. But you can't argue with orbital mechanics. If the object moves in ways that violate predictions based on known forces, either our understanding of physics is incomplete or the object has capability. And if it has capability, if it demonstrates intentional navigation, then every institution that stayed silent, every space agency that withheld data, every platform that suppressed discussion, all of them will face questions they won't be able to deflect with bureaucratic excuses and government shutdown justifications. Financial markets, as Loeb predicted, would experience immediate volatility, not because of physical danger, but because uncertainty at existential scales paralyzes decision-making. What does confirmed technological capability mean for space policy? For defense spending? For resource allocation? For every assumption about humanity's place in the cosmos? Markets don't handle that kind of paradigm shift gracefully. They crash first, adjust later. Governments would face unprecedented pressure to provide answers they don't have. Space agencies would be forced to disclose October 3rd observations immediately, not months later. Radio telescope facilities would have to confirm whether they've been monitoring and what they've detected. The entire infrastructure of institutional secrecy that's been operating for the last 26 days would collapse under the weight of public demand for transparency. But here's the thing about outcome 3. It's the least likely based on historical precedent. Oumuamua showed non-gravitational acceleration, but was ultimately explained through natural outgassing models. Every other interstellar object or comet that's exhibited unusual behavior has eventually fit within natural frameworks once sufficient data accumulated. Assuming 3I Atlas will be the exception, the one object that definitively demonstrates technological origin requires accepting that we're extraordinarily lucky to witness it during our lifetimes, or extraordinarily unlucky depending on your perspective. And yet, the anomalies stack. The trajectory precision, the wow signal correlation, the potential chemical impossibilities, the thermal contradictions, the institutional silence, each individually explainable, collectively unsettling. And if November reveals trajectory deviation, all of those explainable anomalies suddenly become corroborating evidence rather than statistical noise. So what do we do with the next 72 hours? We wait. That's all we can do. Wait for perihelion to pass. Wait for solar conjunction to end. Wait for November reappearance. Wait for amateur observations to start flooding into public forums. Wait for institutions to either release data or continue staying silent. But while we wait, we can prepare. We can set up observation schedules for mid-November. We can calibrate equipment. We can coordinate with distributed networks so that when 3I Atlas emerges, hundreds of telescopes across the globe are ready to capture its position, measure its brightness, track its movement. We can create redundancy, ensure that even if official channels provide nothing, citizen science documents everything. The Galileo project will be watching. 3 observatories specifically designed to detect anomalous phenomena. If probes get released, if there's UAP activity, if something enters Earth's atmosphere that shouldn't, those instruments will capture it. And Loeb has committed to immediate data release, no delays for peer review, no months-long publication pipelines. Transparency by design. Amateur astronomers will be watching. Individuals with passion and equipment and internet connections, coordinating through platforms that institution can't fully control, sharing observations faster than bureaucracies can process approvals. They'll provide the ground truth that official silence tries to obscure. And we, everyone listening to this right now, will be watching too. Not through telescopes necessarily, but through attention, through questions, through refusal to accept silence as an answer when answers should exist, through insistence that publicly funded space agencies serve the public rather than gatekeep information for reasons they won't explain. This is what comes after. Not certainty, not closure, but a moment when we collectively decide whether to trust institutions that have demonstrated through action and inaction that trust might not be warranted. A moment when distributed networks either validate their capability to replace centralized authorities or demonstrate their limitations in distinguishing signal from noise. 72 hours from now, 3i Atlas will be behind a sun, bathed in gigawatts of solar energy, either fragmenting under thermal stress like so many natural comets before it, or enduring in ways that demand new explanations. We won't see it happen. We'll only see the result. Fragments or integrity, predicted trajectory or anomalous deviation, confirmation or catastrophic uncertainty, and then we'll know. Or we'll have new questions, because that's how this works. Each answer spawns more questions. Each observation generates more anomalies. Each explanation reveals gaps in understanding that require more data, more analysis, more transparency than institutions seem willing to provide. The comet approaches its hidden rendezvous. The clock counts down. The silence persists. And somewhere, whether we acknowledge it or suppress it, whether we investigate it or ignore it, the truth exists independent of our willingness to see it. Mid-November. That's when everything either resolves or escalates. That's when amateur observations either vindicate institutional caution or expose institutional failure. That's when 3i Atlas either becomes another footnote in astronomy textbooks or becomes the object that forced humanity to confront what we've been avoiding since that first wow was written in red pen 48 years ago. The countdown continues. The mystery persists. And in 72 hours, the moment arrives when solar fire either unmakes a cosmic visitor or reveals it was never what we thought it was to begin with. We'll be watching. Because even if institutions won't tell us what they see, the sky doesn't lie. The numbers don't lie. And when 3i Atlas emerges from behind 150 million kilometers of nuclear fusion, when its path is measured and its trajectory calculated, and its nature finally tested against the unforgiving physics of reality, we'll know. Or we'll have new questions to ask in the silence that follows. The comet comes. The waiting begins. And the truth, whatever it is, waits with us.